This question here is all about elastic potential energy. So question 1a, right, we've got to complete the sentences and we've got to choose the answers from the box. It's 2 marks, so it's just one word for each box. So we've got a boy in a trampoline, and as the boy falls, there is a decrease in his something energy. So he's falling, which means he was high up. So there's a decrease in his gravitational potential energy. And as the boy falls, then there will be an increase in his kinetic energy because he is moving. So as the boy lands on the trampoline, each spring stretches 0.015 metres. That's key in this calculation because it's in metres, so it does not need to be converted. There's also a clue for that because it's only worth 2 marks. If it had to be converted, chances are it would be worth 3 marks. So we've got the equation formula written out for us. All we've got to do is put in the missing numbers. So we know, all right, that we've got 0.5, that's half. It gives us the spring constant here. So that's 120,000 times the extension 0.015, and that is squared. So that's important that we square that extension, not square the whole calculation. If we square that calculation, you can have a little go yourselves, and you will see it is 0.00225. So if we times this all together, you should get an answer of 13.5 joules. Now we know there are 40 springs on this trampoline. So we've got to times that 13.5 we had, because that was the energy from 1. There's 40 of them. So it's 13.5 times 40, and that will give us an answer of 540 joules. Now if you made a mistake on this one here, let's say you had 14 rather than 13.5, as long as you times it by 40, that error will be carried forward and you will still pick up a mark. Now question D says the kinetic energy of the boy as he lands on the trampoline is 600 joules. And the maximum kinetic energy of the boy after he bounces is 45% of this kinetic energy as he lands. So we've got to calculate the maximum kinetic energy. This bit here is key. So the maximum kinetic energy is going to be 45% of that 600. So we change that to a decimal. So that 45% will become 0.45, and then we times that by 600. And that will give us an answer of 270 joules. So the maximum kinetic energy will be 270 joules. However, you might have noticed it's less. Okay, we somehow lost some energy. So where's it gone? And where's it gone is a typical exam question. And it's the same terminology each time. And where's it gone? Well, it's the energy is transferred to the surroundings. So that's how we get 4 marks on this type of question.